This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.
Introduction to Logic. Proofs, principles, inductions, and deductions. Logic is the art of non-contradictory identification. The purpose of constructing a framework, such as logic, is because our integrations of information can be wrong. And we require a process of creating and cleaning up concepts. What we are looking for is a means of achieving proof, especially proof of principles. In order to do this, we need to use both inductions and deductions. Any philosophical venture trying to construct knowledge with only one half of these methodologies will be absolutely helpless to achieve its desired goals. For a philosophy composed of nothing but inductions will have only first-level generalizations, and a philosophy composed of nothing but deductions will have only primitive mouth noises. To show this, let us start with definitions. Proof. The process of deriving a conclusion step by step from the evidence of the senses, each step being taken in accordance with the laws of logic. Principles. A fundamental, primary, or general truth on which other truths depend. Induction. The process of observing facts of reality and of integrating them into concepts. Deduction. The process of subsuming new instances under a known concept. Since our definition of proof requires the laws of logic, let us also state the laws of logic. Laws of logic. 1. The law of identity. Two entities, x and y, are identical if they share the same properties. 2. The law of non-contradiction. Either x or not x is true, and there is no other possibility. 3. The law of the excluded middle. An entity x has or does not have a property p. Conversely, a property p is either possessed by an entity x, or it is not possessed by x. 4. The law of quantitative comparison. Given two entities, x and y, both having a property p, either x has p more than y, less than y, or is indifferent to y. When x and y are closely similar, it is possible, by using expert judgment, to estimate the dominance of one over another numerically and derive priority from such comparisons. We are looking for a means of proving principles through a methodology of constructing objective concepts and subsuming information from them. Since there is a fundamental integration of epistemology, mathematics, and neurology, we will try to stay focused on these core aspects of this process. As such, we will deal with a basic mathematical epistemology in our cognitions. For example, the brain is capable of perceptually sorting out objects from each other, but that operation is very limited. As such, all animals can perceive single objects, two objects, and three objects. After that, depending on the species of animal, a change takes place where a ratio of differences takes over, such that nearly all animals after three objects cannot tell the difference between 3 and 4 or 4 and 5, but can tell the difference between 4 and 7, or cannot tell that there are 9 or 10 objects, but can tell the difference between 9 and 14. All brains after a certain number of perceivable objects can no longer perceive countability, and the brain switches the task to volume or size differences. As such, you could trick just about any brain by taking a pile of 12 things and a pile of 10 things, Then, after counting out the bigger pile, you offer them the smaller pile, and the receiver will think that this is fair sharing. But try that with a pile of 14 and a pile of 10, and any mammal will know it's being ripped off. As such, we can say that a human being who is conceptualizing the world around him has the ability to perceive two-ness. It's a basic factor all animals need to perceive in order to know which foot in front of their face is which, or which side of their body to look when it hears or sees something. The binary nature and the division of the brain, and the integration of the two eyeballs, two ears, etc., overlapping in the brain provides the animal enough implicit knowledge that it is no miracle that a being that can abstract can instantly conceive of 1, 2, or 3 things. In fact, humans on average can do 7 to 8 objects at once. Let's reduce this to 5 and state that if a person is presented with 5 or less objects, they perceive that information. No conceiving is necessary. As such, when we are starting to abstract and conceptualize words and quantities as explicit knowledge, we never need to prove one thing is one thing, or that 2 different things are 2 different things. All the way up to 5, so long as we can instantly check if all of our fingers on one hand are still there, then simply looking at that quantity is a proof of its own quantity. Again, proof, the process of deriving a conclusion step by step from the evidence of the senses, each step being taken in accordance with the laws of logic. 5 objects is evident in the senses, so no steps are needed. But applying the essential logic anyway, 5 objects are identical to the quantity 5, as, for all of the properties of fiveness, those 5 objects have them, and for all of the properties those 5 objects have as being 5 things, are also the properties of fiveness. 5 objects is not 4 objects, nor 6 objects, nor any other number but 5. 5 objects does not lose any or all of the properties of fiveness at any time. Given 2 groups of 5, they are indifferent to each other. Given this, we can say that when we see 5 objects, we can nearly automatically construct the statement, "There are 5 objects here," or "I see 5 objects," or "5 objects are in front of me," etc. However, if for whatever reason this breaks down, the ability to count one object should stand. And if you stop and slow down, you can use one finger for each count of 1 until you have proven that there are 5. When we are forming concepts, it is possible that for all the quantities of 5 and less, that they were integrated as a concept of quantity amount without requiring the concept of 1 first. It is not the case that we conceptualized 1 first, and then, after conceptualizing and mathematically practicing with ones, we achieved 2, and so on. A baby book teaches all 5 concepts separately and at the same time. As such, at the first level of conceptual knowledge, 1, 2, 3, 4, and 5 are 5 different concepts. The child is not yet ready to abstract a relationship called quantity yet. It is a type of pattern, a pattern which does not depend on shape or structure or spatial rearrangements, but a pattern nonetheless. And as such, there is a first-level inductive generalization that this is 5. Then we learn the basic algebra, or statements one can formulate with this knowledge. For instance, 1 less than 5 is 4, and 1 more than 4 is 5, and 1 more than 1 is 2. which is 3 if you add one more, and that becomes 4 if you add another. Once more, 5. These are deductions from the 5 different concepts. 4, by pure perceptual pattern recognition. 5 can be spatially separated into 2 groups at such a distance that suddenly the automatic perception of 5 things becomes more similar to 4 things here and 1 thing there, or 3 things here and 2 things there, or 2 things here and 3 things there, or 1 thing here and 4 things there. We can do the same thing to 4 things and the 3 and 2 things. Therefore, the idea that 1 plus 1 equals 2 is a deduction from the induced concepts, which comes years after first forming these concepts. The same is true of shapes. For the shapes of a circle, a triangle, a rectangle, and a square are visual patterns that are instantly perceivable. It is only years later that the deduction that shapes have sides and corners is discovered. It was implicit in the shape, but just because your mind contains the pattern does not mean that your mind contains the knowledge. A square has 4 sides and 4 corners is a deduction from the induced, this is a square, this is 4, these are edges, these are corners. There are 4 edges and 4 corners. This square has 4 edges and 4 corners. All squares have 4 edges and 4 corners. Therefore, as the courses of physics, math, chemistry, biology, philosophy, etc. are presented on this channel, the methodology of moving from the first level generalizations up to our goal of explaining our quantum consciousness and the space-time vibrations will be based on this foundation of proof, and each principle or general truth we uncover will be proven using the combinations of inductions and deductions. Proof is reducible to causal reality. It is through causal interactions with the world that our minds construct any concept of proof at all. Therefore, any and all disagreements in regard to the idea that proof was not proven, or that there is no proof of reality, or any and all sentences, such as, prove to me that 1 is 1 without referring to objects or math, can and will be rejected instantly, as the only reason one can be skeptical of anything is by first accepting the difference between what's real and what is not. To suggest we might live in a dream world is proof you know the difference between dreams and reality, and that your skepticism came from waking up from a dream you thought was real, only to realize that it was another dream. But you very quickly realized it was a dream. To abstract that worry beyond your sleepy state of consciousness is unnecessary. And if you were as skeptical as you claim, and you thought it was still a dream, why did you still decide to go to school or work that day? Reality is the only reason you discovered skepticism. When we prove something in our courses, then, we will be able to see the full extent of concept formation, such that we will be able to visualize the inductions and deductions mathematically, neurologically, and epistemologically. We will be able to see both the process of generalizing and the process of specializing, and will see why one without the other would be a fool's errand.
This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.